Okay, we're still on chapter 7, section 8, improper integrals. This time we're going to do type 2. The type 2 improper integral is about the boundaries. Here we don't have infinity or negative infinity. So we have this is case 1. So type 2 case 1 is you have the integral from a to b of f of x dx, where the function f of x, the integrand, it's the function f of x, is undefined at x equals b, at the upper limit of integration. Yeah, so that's case 1. So to solve this integral in case 1, we're going to again change this improper integral as a limit. Since the function f of x is undefined at the upper limit of integration, so what we're going to do is go where the limit of integration is, change it to t, and take the limit as t approaches b minus. Okay, so basically you have a, b, right? So this is like the interval on the number line, so a and b. So when you replace b by t, then the limit, so x will approach b from the left, right? So when x, so it's going to approach b from the left, which is b minus by definition. So we write the limit as a t approaches b minus of the integral from a to t now of f of x dx. And then we do the integral, and then after that we apply the limit to the result. For case 2, the function f of x is undefined at the lower limit of integration at x equals a. So to solve this case 2 of type 2, we're going to go where a is, we're going to replace it with t, and take the limit as t approaches a from the right. Because a is here, so x will approach a from the right side as you're facing your piece of paper. So then you solve this limit, you solve this integral, and then you take the limit. For case 3 basically is the function f of x is undefined at a number between a and b. So let's call that number c. That is somewhere between a and b. That's where the function is undefined, at c. So that makes us split this one integral into 2 integrals. So we're going to integrate from a to c plus the integral from c to b. So that brings us, when you integrate from a to c, so the function is going to be undefined at the upper limit of integration, which makes this case 1. And then the second integral from c to b, since the function f of x is undefined at c, that makes this case 2. So again, the case 3 is case 1 plus case 2. Okay. All right, so let's go and do some examples. So the question usually is to determine whether the integral is convergent or divergent. Okay. So we look at this integral, that's case 1 of type 2. Why? Because when x is 3, this function, so if you plug in a 3 for x into the function f of x equals 1 over square root over 3 minus x, I got it from here. So when x is 3, you're going to have 1 over 3 minus 3 under the square, which is 1 over square root of 0, which is undefined. So the function is undefined at the upper limit of integration, which we know is case 3. So how do we deal with case 3? So what we're going to do is change this. Okay, what happened here is because I'm going to integrate, so to get rid of the square root, we're going to change it to a fraction, exponent 1 over 2. And then we bring it the numerator, which is at quantity 3 minus x raised to negative 1 over 2. But the limit, so it's going to be the limit as t approaches 3 minus. T is going to approach 3 from the left. So now we're going to do the integral, This integral can be done by the U substitution. If you let u be 3 minus x, and then du is negative dx, so negative du is dx. So we plug in u, and we plug in dx is negative du, and okay, so here we did it here. Okay, so we get u to the negative 1 over 2, and then times negative du, and we bring negative sign outside. We integrate u to the negative 1/2, which is u to the negative 1/2 plus 1 over negative 1/2 plus 1, and they give us u to the 1/2 over 1/2, which when you divide by a fraction, you flip and multiply, you get negative 2 times u to 1/2, but u is 3 minus x, so you replace u by 3 minus x. So this is the answer that I'm going to bring over here. So this integral, its answer is there, but I'm going to evaluate this answer at x equals 2 and at x equals t. So first I plug in a t for x. I get 3 minus t over here. Quantity 3 minus t raised to 1/2, and then times negative 2 minus. Then I plug in a 2 for x. You get a 3 minus 2, which is 1 raised to 1/2, which is 1 times negative 2 is negative 2. Negative 2 and then minus makes it a positive 2. So I have these two terms. Then since I'm bringing my limit down, now I can take the limit. So you take the limit of the first expression plus the limit of the second expression. Since this is a constant, the limit of a constant is always a constant. So limit of 2 is 2. Here, when the t approaches 3, basically you're picking numbers near 3 from the left, like 2.999, which give you a small number that is closer to 0. So basically this will go to 0. 0 times negative 2 is 0. 0 plus 2 is 2. So 2 is a finite number. Again, we say that the improper integral converges because the 2 is a finite number. So that was case 1. For case 2, we have the case where the lower limit has a problem. Okay. So we know we're going to change this to the limit as t approaches a plus. So an example is this. You have the integral from 6 to 9 of 5 over quantity x minus 6 cubed. The function is 5 over quantity 6 minus x minus 6 raised to the 3rd power. If you plug in 6 for x into the function, you're going to have 5 over 0, which is undefined. So we know this is case 2. So to change case 2, this improper integral is a limit. We take the limit as t approaches 6 plus, and then we go where 6 is, we replace it with t. So we then, to do this, again, it's going to be the U substitution, so we need to bring this to the numerator, which will change the exponent from positive 3 to negative 3. And we let our u be x equals, u equals x minus 6. So du is dx. So basically, you're going to have 5u to the negative 3 du. I'll use the power rule of integration to get 5 times u to negative 2 over negative 2, which you can write as negative 5 over 2 u squared if you bring it down. And then you replace u by x minus 6, you get negative 5 over 2 times quantity x minus 6 squared. So this is the answer of the integral without being evaluated yet. So that's the answer. We put it here, and then we're going to evaluate this at x equals 9 and x equals t. First we plug in 9 for x. You get 9 minus 6, which is 3 squared. So that gives us 9 times 2 is going to give us 18 eventually. And then you plug in x equals t, you get negative 5 over 2 times t minus 6 squared. So this is a constant, this is a number. Okay, so when you are applying the limit to a number, it's going to give you the number. So the limit of negative 5 over 2 times 3 squared is just give us the number. Plus, when you take this limit, so here we have to be careful. When you take the limit as t approaches 6 plus of 5 over 2 times quantity t minus 6 squared, you basically taking the values of x near 6, but to the left of 6, like 6.0001. So if you put 6.001 for t, So 6.0001 minus 6 is going to give us 0.001. When you square it, it gives us even a smaller number. Okay, so it gives us negative 8. It gives us 10 raised to negative 8. But when you, because that is on the denominator, but when you move it on the numerator, then that 10 to the negative 8 becomes 10 to the 8th, which is you have 8 zeros. Okay, which is a large number, large positive. So this limit will give us a large positive. Large positive translation is infinity. So you have a number plus infinity, which is infinity. So we say the integral diverges. So for case 3, we have that's when we split the one integral to become 2, because the function is undefined at some number that is between a and b. Here's a case. You have the integral from 0 to 5 of quantity x minus 1 all raised to negative 1 over 5. So if you rewrite this function as 1 over quantity x minus 5 raised to 1/5, when you evaluate, so you can see on the denominator is 0 when x is 1. So f of 1 is 1 over 0, which is undefined. X equals 1 is between 0 and 5. Okay, so c is 1. A is 0, b is 5. So the function is undefined at 1. So we're going to split this integral as the integral from 0 to 1 plus the integral from 1 to 5. So you have two integrals. So this is case 1 because the function is undefined at the upper limit. This is case 2 because the function is undefined at the lower limit. So we're going to start solving for I1, this one here. So we have the integral from 0 to 1, and we change the limit. So we go where 1 is, we replace it with t, then we take the limit as t approaches 1 minus of this new integral. This integral is just the U substitution. Okay, so we use the U substitution to get the answer. You get quantity x minus 1 raised to negative 1 over 5 plus 1 over negative 1 over 5 plus 1. This is the rule of integration, and then we're going to evaluate it at x equals 0 and then x equals t. So first we start x equals t, we plug in t for x, we get t minus 1 raised to 4 over 5 divided by 5 over 4 after dividing by a fraction. And then we plug in 0 for x, so 0 goes there, we get negative 1 raised to 4/5, and then times 5 over 4. Negative 1 raised to 4 over 5 basically is that you can take negative 1 to the 4th power, it gives you 1, and then raise the 1 over 5, which is still 1. So this gives us 1. 1 times negative 5 over 4 is negative 5 over 4. Here, so we have two terms. Okay, we take the limit of the first term. When the t approaches 1 minus, okay, basically this goes to 0. So the answer here is negative 5 over 4 for the first integral. The second one, we integrate from 1 to 5. We change it as a limit, t approaches 1 plus of this new integral. But it's the same integral except the different limits of integration. So we already know the answer for this integral. You can just copy it down, which is what we wrote here. So the answer is already this. Now all we need to do is just the evaluation. Okay. So we're going to evaluate this answer at 5 and the t. So we plug in 5 first for x. We get 4 raised to 4/5 times 5 over 4. Then we plug in t equals x. We get t minus 1 here. So the limit of a constant is a constant, so you get this number, minus, when you take this limit as a t approaches 1 plus, this will go to 0. So this is 0, and then we get this finite number. So therefore, the original integral Integral from 0 to 5 of quantity x minus 1 raised to negative 1 over 5 dx is then the first answer plus the second answer. But these are numbers, so they are finite numbers. So we say the integral converges.